Welcome back. Who was yesterday on Dev Challenge Accepted session about cars? Can I see? Without the volunteers, okay. So
and without t-shirts.
Yeah.
If you listen carefully, you should know what ADAS is. Yes?
Who knows what ADAS is? You can use Google, the fastest win.
No.
But
without, I think it's, yes, without Bosch.
Without Bosch. Someone, you can use Google, the fastest wins. Sorry? Warm. ADAS. Yes!
Okay.
Yes, sir, you win a wonderful t-shirt. It is...
Извинявай, аз мисля, че той отговори. Да, добре. Окей, но да. Благодаря.
Yes, this is advanced t-shirt.
So, our next speaker is one of the leading managers in Bosch in the sphere of ADAS testing. He has more than 20 years in the automotive area and has vast experience in testing and developing safety braking system and ADAS systems, especially on central computing units.
Mr. Noller is passionate mountain biker, climber and skier. His private challenge accepted is to climb all the peaks in the Alps, and currently he has just 9 to go. Ladies and gentlemen, Achim Noller! Welcome to Bulgaria, welcome to our stage.
Thank you so much. Yeah, warm welcome from my side as well, and it's a pleasure for me to be here in Sofia. As talked already, my name is Achim Noller, and from Bosch in Germany, and besides my role as department head of system and software testing there, I'm also leading the worldwide test community from Bosch, and within this I have also a very close cooperation with our test centers here in Sofia, from Bosch Engineering over here, which is right next to the door. And I'm really happy that I today have the possibility to give you some insights about ADAS testing and how we test our automated systems and what are the challenges behind and how we cope with these challenges. Okay, but to start with, I want to give you an overview what is an ADAS system about. Some might have heard of this, some might not. However, I would like to start how to get such a system running. To run such a system, you need many sensors. I just placed here some of them. You, for example, have a radar in the car to detect objects with radar sensor. Higher evaluations of ADAS also need a LiDAR to use laser sensors to detect objects. And in addition to that, we also use video cameras to detect objects. And for sure, also ultrasonic signals, especially for parking features. So why do we use these sensors? If you just look into what to do with that, I brought you a very simple picture. This shows a modern ADAS car with a 360-degree surrounding model that is created out of all the sensor data. And as you see, you can cover 360 degrees with the different cameras, radar sensors, ultrasonics, depending on your application and your function we want to do. This is the base that the car has eyes and can see in a way like a driver is doing that, at least in some cases. But this is the half part of the story. The other part is we have to act the car as well, and we have to manage it. I just brought a small picture here where you see what is beside all the sensor set needed to get the ADAS system running and where we also need to act in our functional devices and in our functions that the system is working in the right way. For sure, we need to steer and to brake, but not only that, we also need to influence the powertrain, for example. And I just have one sign marked in blue and the other one in gray. This depends on, sometimes you need these systems even doubled. For higher safety levels, if the functionality get more automated, you even need redundancy in to reach the different safety levels. Because you can imagine if there is a function where the driver is no longer into the game, then if a system is failed, it can come to quite severe situations, and we have to avoid this. Besides the powertrain, navigation also is a quite important topic for other systems. And also here, we have to look into the topic and see how we can handle navigation, and beside navigation, also such called cloud-based applications. To give you an example about a cloud-based application, it is very useful if you do an automated drive to know where road construction is going on. This is usually not in your usual navigation system and it changed also drastically and in short times. So you need to load this data from a database that this is always in a current state in your car. That's what the ADAS system is about. Now, what means this of size of systems and size of codes? I just brought two figures with me. One is the software size of a modern high-class car or upper-class car, which is currently roughly around 100 million lines of code. With this, a modern ADAS system has 20 to 30 million lines of code, which is a quite high number. And I don't know if something of you have ever heard how much paper is 1 million lines of code. It's roughly 18,000 pages if you print this, and this gives you a smart imagination how complex and structured systems are meanwhile. And when we're looking into the near future, this trend gets even worse, let's say like this. What is the reason? Modern car architectures are driven from putting domains together more and more. This has several reasons. I can just give you one example on that. For example, last few years, it was usual to have an independent camera, which is taking the function of the camera, doing the object detection, and also the related functionality is in that camera included, which is under the windshield. Now, it is not that nice to have a camera in the windshield. It blocks the sight of the driver. It has problems with thermal dissipation in summertime, and so on. So it is decided in modern architectures to put this in the central ECU unit, which makes this bigger and even more complex. On the other side, computation power is very expensive. So in most cases, driving and parking are completely different applications which you not need to bring it together. If you are driving, you are not parking, and if you are parking, you are not driving. So why not using the computation power for both? But also this is then an increase, a massive increase of complexity in your software system. Why is this so important for testing as well? I just brought you here one classical book of software development. Fred Brooks, he was a guy in IBM who developed the first operating systems with more than 100 or 200 software developers in one project. And what he found out was it is not able to scale from very small software projects to bigger ones. A small software project, you can imagine, you have a small team of 6 or 7 people. Everybody knows what is in there, what is out there. You can keep it in a lean way. But as long as you are you size up, you have to define interfaces. You have to split the work. And it is getting more and more complex. And he looked at his first projects and made a lot of estimations, which are meanwhile also proven. And what he came up with, in modern software systems, you have 1/3 effort to plan, also the interfaces, also your software structure, your architecture. 1/6 is coding, 1/4 is module testing, and another 1/4 is system testing. Means writing the code is the easy part of the story. But getting a complex system established in the right way, main part is testing. 50% at least is testing. Having this in mind, and 100 million lines of code in mind, you have a quite big elephant that you have to work on. Now, how to handle such an elephant? The elephant is too huge that a small team can handle this on its own. So you have to cut this elephant into pieces. To give you a short example, how many people are working there, sometimes you have a single project, 300 to 400 testers working in there. And so the big question is how to get the system safe, how to get it in a good quality, and how to get it tested in the right manner. And you have to be careful because there are some risks from my point of view. If you cut the elephant into pieces, you don't have to create new elephants that are as big as the old ones. You also have to carefully look that you really take the interfaces into account. And the most important thing, have still the picture of the elephant into mind. Keeping this picture a little bit in mind, we now look back into other systems and how we can handle them. So what we did, we have taken up several levels in the car to get the system divided and to get it structured in a good way. For this, I just listed down here the different levels we have taken up. There is a vehicle world, the vehicle itself, the domain, like a ADAS domain or braking systems. There's an engineering domain, for example, hardware and software. Or you have also components from electronic to software, down then modules and so-called elements. If we look into that, if we have a good system architecture that can structure us such a huge software project. And now is the question how to link this to testing. I don't know how many of you out of the automotive development. Usually we are working in the so-called V model. A V model means you are looking first of all on an architectural level. Then you have a so-called detailed design. You are implementing your software. Then once implemented, you test your software, you test your design, you test your architecture, and at least everything in a safety relevant system has also to be traceable. Otherwise, you won't be able to release it later on as a safety system. And for this, we are going through like a V in each and every area. And what we do to get such a big and huge system derived into different levels is to split it up and handle it always in such a V model. Means we are very close to engineering and to the software developers on the one hand, and we have to ensure that each of this level is tested in a right manner and in the right way. You can understand it's not an easy task, and at the end, the interfaces are very important. So you really have to look that all of your tests are really working together and cover each and everything. For this, it is very important to have an overall test strategy and release strategy for such projects that cover you the complete project and give you the possibility to release it in a safe manner. Now, going a little bit more into the detail of what is important to reach such a level where we can release a ADAS system on a safe way on the road. I have just put down here 5 key elements where we are looking into. One is the ISTQB standardization. There's an International Software Testing Qualification Board, which said there are several rules that are more or less the basic rules for all testing in automotive. This includes, for example, to be right from the beginning, test has to be included in the project. We have a close alignment with the architectures. We plan together with the software developers and the architectures our testing, and we define also in the architecture interfaces that can be tested well. And all of this is included in ISTQB and gives us the base for valid and good kind of testing. On the other hand, and I will show you later on a little bit an example how we handle this, we really have to look how to reuse as much as possible to get the effort in a way that it can anyhow handled. Because think about 100 million lines of code to test it each and every time is really not the best idea. You will need thousands of test engineers at the end of the day. So you have to really focus on to reuse. And to focus on to reuse starts with your tooling around, with your frameworks that you really can apply reuse later on in projects. Another important part, as I mentioned already, the strategy of your overall testing. Don't lose the overall picture of the elephant out of the mind. It has to fit together at the end, and it has to release a complete system, a ADAS system or product. Simulation is a very important part that we are using as well, because as early we can test, as better for our development and our overall system. As early we can find bugs, it is better for our overall development and system. And often you have the practical use cases that hardware is only limited available or late in the project available. So if we can really use simulation and test on the earliest stage that is possible, it is an absolute benefit for ourselves. And beside this, we also try to test always on the lowest level that are possible to be ensured the modules or the smallest parts are working already fine. There will be enough problems later on by putting all the stuff together and get it running again. And at the end, very important, look at your framework. Is it efficient? Can it handle multiple use cases? Do you also test the right topics? Sometimes it makes no sense to do a same test again and again. It will get you no benefit anymore. You really need also to have the capability, beside testing requirements, also to test the corner cases of your system and think about where are the weak points of my system, and we should have really to accept this challenge to find especially these corner cases. Because especially in automotive industry, you have the usual case that production is going into 100,000s or even millions. And I can promise you a bug that is in the system will occur in some time, and it will occur sure. So it has to be our challenge to find them all before they are out in the street. And I think you know it out of several news that it is really a big mess if a recall has to be done. It's a lot of money that will be lost there for the car manufacturers. Okay, I just brought now an example on our ADAS sill and hill concept, which, by the way, we are using also here in Sofia. This is the picture of our framework which we are using. On the one hand, we have the possibility to have several simulation engines, and we try to be as flexible as possible. Then we have a so-called SIL core, a software in the loop core, which allows us to take sensor models in, which allows us to take vehicle dynamic models in. And we have there a stable core that provides us the simulation for different ADAS systems. This is our core, and this is what we are using as a platform, which then will be also provided in multiple projects. And on the other hand, we also have a so-called hill test, a hardware-in-the-loop test, which is then mainly with the real hardware in. And together with the hardware, we often have customer-specific parts that we have to test. Think about the communication in the car. Each car manufacturer has a different communication, for example, or also deep diagnostic features or anything else. We can better test than with a hill system, but reuse already what we done in the SIL and just adapt what we need then for the dedicated customer projects. And so we are managed to find an effective way to really handle such huge projects. Now, I just wanted to show you a little bit how it looks like and what is, for example, done here in Sofia as well. I just brought here two ADAS features. One is to park a car automatically, and we are simulating this in an hill or in the SIL environment. And this is now some feature that was tested here in our Sofia test center. You see the car that is arriving, and now he detects the cars on the side road. He has to measure the length of the free parking space and then calculate the route to get into the parking lot. And before doing this out on the road, we can already do these tests in the SIL environment only based on the software and the functionality, and test it there and see if it's working in a correct mood and try to find the errors that could be in that system. just brought a second example, which is the automated emergency brake. There is a function, which is also safety critical, that a car should stop automatically if, for example, a pedestrian is crossing the road and was missed by the driver and he missed to brake. So the car has to react quite fast, detect and with the radar and video sensor that there is a human on the street, and then brake quite as hard as possible that we don't injure the pedestrian. And also this we already can simulate and test before we bring it in the car and on the road, and you can imagine how much effort it is to test such a scenario in real life. It is possible, but don't worry, we don't have people there. You can, there are possibilities, but it is quite not that easy, and it is very beneficial there to do that for us. All right, that's what I wanted to show you today. And if you have questions, please feel free to ask.
Danke, danke,
Thank
Herr
you.
Noller. So, any questions? There is a question there.
Hi, sorry if my question is silly, but I cannot wrap my head around, okay, at some point you need to test the system as a whole, and you need to run regression testing. Do you rely more on automated testing, and isn't it dangerous in this situation? Because it's very responsible. I honestly don't know how you sleep at night.
For sure, we are doing tests on all levels. Yeah, but as the system overall is a quite big one, we have to start at the earliest and continue testing through the complete life cycle of the project. This is the one thing. We also do, for example, continuous testing each and every software step and so on. And finally, we will also go in the car and realize it there that everything is safe, absolutely. So there are really these different kind of levels that I showed, starting from a software module up to a vehicle level. Hope this answers.
Thank you. There's another question there.
Yeah, thanks for the great talk. I wanted to ask, nowadays, most of the cars are equipped with cameras. Do you use the feed of these cameras to make your system smarter from production? So from cars running around the streets?
Yes. Topic is, it's also started to use artificial intelligence into cameras especially. And to get artificial intelligence software tested, there is at the moment, for example, no good way then to really run in a shadow mode this function as long as you have enough kilometers that you can release this function. Such topics are already implemented partly.
Thank you. There is another question. No, no.
Може би копчето да се натисне.
Yes.
The online audience will not hear.
Now?
Okay.
So basically, I really like the simulator part. So that's a good one. But what about after that? I mean, you gotta try the system in real life, I guess, to be 100% sure that it's working right. So basically the question is, what is the next step after a simulator? Do you actually have somebody? Okay, so you have the car and you have somebody and they're crossing the street, nonchalant, you know? And do you just be like, okay, I've tested it with a simulator,
No.
let's try it in real life?
No.
Or how does that work? Because for sure, like, how do you
No.
sleep at night? So it would be nice to know before
No,
going into this industry.
In general, we have a test track, to be very honest, and then we have an automatic, how to say in English, dummy, which is mechanically pulled into the street. That's how it's getting tested at the end of the day.
Thank you. There is another question there.
Another question? Okay.
The last one.
A few too many.
And you can ask further questions during the rain break, which we'll make it right now.
Okay, well, a really good presentation. I'm interested what is happening with pedestrian when you're testing instant braking of the car. What happens if the radar stop working? Does the car is going to stop, the other systems are going to proceed working, or you're going to show something that the systems are not working and then you're going to hit the pedestrian? It's important because...
So, I hope I got your question right. On the one hand, if you would have this system not in, the pedestrian would have hit anyhow. And for sure, you have to look that your detection rate is as high as possible. Not only for pedestrians, also you can have a look on cyclists, you can have a look on animals. And so on. Yeah, and for sure, yeah, it will be there no absolutely 100% insurance that the system will detect it, but we are at 99%. And for sure, to live or to see such a braking in life, it's really impressive, exactly. Because if such a emergency brakes happens, the brake will be pulled to a maximum. It is really impressive to see that, how hard it is, how hard the car is brake, and I think no human will do like this. So anyhow, it is a big beneficial for the safety on the streets, but for sure, every case that is known where a system is not working absolutely correctly will be used to get the system better in the future.
Okay. Thank you very much.
Thank you.
Thank you. Your big
applause
applause
for
for
Achim
Mr. Noller. Here is your present.
Thanks a lot.
Coco.
So, 10 minutes raining. Coffee break for 10 minutes.